Today's lesson, we're going to be learning about direct and partial variation. Let's begin with learning about direct variation. Direct variation is a relationship between two variables in which one variable is a constant multiple of the other. A constant of variation. In a direct variation, the constant multiple is often represented by m, which is slope. If y varies directly with x, then the constant of variation m can be identified by m is equal to y over x or y is equal to mx. Both of these formulas are indicating the same information, but they're just rearranged. In this formula, m is isolated, and just rearranging our variables, in this formula, y is isolated. When you graph a linear relation that is direct, your line will always cross the origin. Remember that this point right here, the origin, is 0.00. X is equal to 0 and y is equal to 0. So in example 1, let's try identifying whether these table of values represent a direct variation according to the points included in the table of values. So knowing that the linear relation must pass through the origin 0, 0, we should have the point 0, 0 in the table of values for that relation to be considered direct. Let's focus on example A. So we're looking for point 0, 0. When x is equal to 0, y also must equal to 0. When x is equal to 0, in this table of values, y is not equal to 0. So that means that if we graphed this relation, the line would not pass through the origin. So it's not direct. Let's look at the table of values in example B. When x is equal to 0, y is also equal to 0. These are the coordinates that create the point 0, 0, or the origin. So if we graphed this relation, it would go through the origin, which means that this is direct variation. Another thing to keep in mind when determining whether a table of values represents a direct or partial variation is whether or not this relation is linear or not in the first place. We learned last lesson that we determine from a table of values whether a relation is linear or not using first differences. So we see that this relation is going to pass through the origin, but it also has to be a straight line or a linear relation for this to be considered direct. So we also have to perform first differences to determine whether or not this is a straight line, a linear relation. So 3 subtract 0 is equal to 3. 0 subtract negative 3 is equal to 0 plus 3, which is equal to 3. And negative 3 subtract negative 6 is equal to negative 3 plus 6, which is equal to 3. Assessing my first differences, they are constant, which means that this is a linear relation. Since the first differences our constant and the relation passes through the origin, therefore, this is direct variation. Okay, so in order for it to be direct, it has to pass through the origin and the relation must be linear. Example 2. Determine the constant of variation. And remember up here that the constant of variation is your slope. So here, determine the constant of variation. It's asking us to find the slope. Then write an equation in the form y is equal to mx. Now also remember from up here that a direct variation has this equation. So a straight line that passes through the origin, when written out in equation form, would be y is equal to mx. So in example 2, first it's asking us to find the slope. Determine the constant of variation. Then it's asking us to write it in equation form, in the form y is equal to mx. A. The distance a car travels varies directly with time. The car travels 320 kilometers in 4 hours. It already tells us that this is a direct variation because it says it varies directly. The question is asking us to use the formula y is equal to mx. Now we're given the independent variable and the dependent variable. Remember that the independent variable is your x and your dependent variable is your y. Let's identify them in the question. We have distance and we have time. Now remember from previous lesson that your time is always your independent variable. How far you travel depends on how long you were traveling for. So your time is always your independent. So if time is your independent variable, your dependent variable is distance. Your independent variable is x, and your dependent variable is y. So in the equation, y is equal to mx, your y is going to be your distance value, which is given to us. It tells us that it travels 320 kilometers. So I'm going to replace y in my equation with the value for y, which is 320. And we're trying to find slope. Remember the question says determine your slope, the constant of variation. So m will stay a variable, and we're given the time value, which is 4. So where I see x, which is my independent variable, I'm going to plug in my time value, which is 4. Okay, so again, I'm trying to find m, so I need to rearrange this equation a bit. I need to bring my 4 over to the other side so that m is isolated. And so 4 is multiplication on the right. So when I bring it to the left, it's going to become its opposite operation, division. 320 divided by 4 is 80. Okay, so the question is asking us to write an equation in the form y is equal to mx. So in step 1, we found the value of n. So in step 2, we're going to write an equation in the form y is equal to mx. Because that equation, y is equal to mx, represents direct variation. And it told me in the question that this is a direct variation relation. So starting with y is equal to mx, I'm going to leave y and x as variables, and I'm only going to replace my slope variable with the value that we found in step 1. Y is equal to 80x. When you're writing equations, your variables y and x will stay as variables. Part B. The cost to be a member of the Harry Potter fan club varies directly with time. Sally spent $85 and has been a member for 5 months. So we're still trying to find slope, our m. So our first step is still finding slope. I'm going to begin with my equation y is equal to mx because I know that this relation varies directly because that's what it told me at the beginning of the question on the other page. In order for me to find slope, m, I must know what y and x are. I can't solve for m if I don't know what y and x are. So I need to look into the question here in part B, what my y and x values are. So it says that Sally spent $85 and has been a member for 5 months. Now remember, months is a unit of time. And remember that time is always equal to your independent variable. And your money is your dependent variable. So I'm going to substitute my x and y values. So y is 85. And we're trying to find, and time is 5. Now I'm going to bring my 5 over to the left side, and it will become its opposite operation. 85 divided by 5 is 17. In step 2, we're going to create an equation. So it has to be in the form y is equal to mx because this relation varies directly. We're going to leave y and x as is, as variables, and just replace our slope variable with a numerical value that we found in step 1. Example 3. The Frederick family is visiting their cousins for the holidays. They travel for 250 kilometers to get to the house. Distance is represented by variable d. So instead of using variable y to represent distance, this time we're using variable d. So we're going to replace y with d. And varies directly with time, and there is the variable t there that we're going to represent time with. So instead of using x to represent our independent variable, we're going to use t. It doesn't actually matter which variables you use. You don't have to use y and x, but what doesn't change is variable m, your slope. M always represents slope. Part A, when t is equal to 0.5 and d is equal to 43, find slope and write the equation relating d and t. So instead of using y is equal to mx, I'm now going to use d is equal to mt. And it tells me that d is equal to 43 and t is equal to 0.5. I'm going to bring 0.5 to the other side. So 43 divided by 0.5 is equal to m. 86 is equal to m. And now we need to create an equation. So instead of using y is equal to mx, I'm going to use d is equal to mt. I'm going to leave d and t as variables and just replace m with the value that we just found. And we're done. What does the constant of variation represent? Remember that constant of variation, that is your slope. Since we found that slope is equal to 86 in part A, then our constant of variation is 86. And in the hint, it says slope as a rate of change. Remember from a previous lesson, the rate of change is your slope just with units. It's the same slope value in a unit rate. So in this example, with the Frederick family traveling, the constant of variation, 86, is the speed that the family was traveling in. So the constant of variation, your slope, is equal to 86, and now we're going to convert it into a unit rate by adding units. Therefore, the constant of variation is 86 kilometers per hour. Use the equation to determine how long it will take the Frederick family to reach their destination. So we created the equation d is equal to 86t. And it's asking us to determine how long it will take. We're trying to solve for time. Which is variable t. We were provided the information that they traveled for 250 kilometers. So that's our distance, or variable d. And we'll use that down here. So we'll sub d is equal to 250 into the equation. And solve for t. I'm going to bring my 86 over to the other side, and it'll become its opposite operation. 250 divided by 86 is equal to t, which is equal to 2.9. Therefore, it will take approximately 2.9 hours for the Fredericks to reach their destination. Example 4. Amir works part-time at a local bookstore. He earns $7.50 per hour. Now remember that hours is a unit of time. So that's our independent variable. And dollars is a unit of money, which is our dependent variable. In part A, it's asking us to describe the relationship between Amir's pay in dollars and the time and hours that he works. So we know that he earns $7.50 per hour. That's a unit rate. Now, what does that actually mean? It means that every 1 hour, Amir earns $7.50. Amir's pay varies directly with time. If Amir doesn't work any hours, he's not getting any money. The more hours he works, the more money he earns. That is a direct variation and a word problem. His constant variation, which we know means slope, is his earnings, $7.50. Illustrate the relationship graphically and represent it with an equation. So let's create a table of values in order for us to have points to plot on the grid. Our x values or t values are already given to us. Our y values or p values we need to create. So remember that he gets paid $7.50 per hour. Let's write that at the top. $7.50 per hour, which means $7.50 for 1 hour worked. Remember this when we are filling in the p values in our table of values. So when Amir works 0 hours, what is his pay going to be? 0. When Amir works 2 hours, what is his pay going to be? Well, we know that for 1 hour, Amir gets paid $7.50. So how much would that be for 2 hours? For 2 hours, we would take our 750 and multiply it by 2. $7.50 times 2 is 15. So for 2 hours of work, Amir gets paid $15. So what about for 4 hours of work? Well, that's another 2 hours of work. So we would add another $15 to what he was already previously earning. So 15 plus 15 is 30. And for another 2 hours of work, we would add another $15 to his pay. So our x values, or our t values in this example, are increasing by 2, while our y values, or p values in this question, are increasing by 15. So our x values are increasing at a constant or evenly spaced. And so our y values are also increasing at a constant or evenly spaced. We can see the relationship between x and y, or t and p. As t increases by 2, p increases by 15. Now we've completed our table of values, so we can go ahead and plot these points on the grid. I'm going to label my axes with the variables that were given to me in the question. I'm going to title my graph with Amir's earnings. I'm going to number my axes with an appropriate and balanced scale. And I'm going to label my axes. My independent variable is time worked in hours. And my dependent variable is pay in dollars. Now I'm ready to plot my points. I'm going to begin with the first coordinates, 0, 0, which is my origin. Next point is 2:15, 4:30, 6:45, 8:60, and 10:75. And then I'm going to connect my points with a ruler. And I'm going to include an arrow that represents the continuation in that direction if more points were to be plotted on this grid. So I can already tell just by looking at the graph that this is a linear relation. I can also tell from my table of values that this is a linear relation because as x increases or decreases at a constant, my y's are also increasing at a constant. I know that this is direct by looking at my graph because my linear relation is passing through the origin. I can tell that this is direct variation from looking at my table of values because it includes 0.00. So we're going to create an equation, and I'm going to create it in part C because we ran out of space in part B. 1 week, Amir works 9 hours. Find his pay for that week. So we're going to create an equation in the form y is equal to mx because I know that this is direct variation for all the reasons that I just stated. So instead of using y and x, remember I'm using p, capital P, and t because those are the variables given to me in the question. And I need to determine what my slope is in order for me to create an equation. I'm going to reference my graph. So slope is equal to rise over run. So for one hour of work would be right here. So for 1 hour of work, Amir makes $7.50. That is my slope. I can also reference my table of values to determine my slope. Remember that your slope is equal to many things, rise over run, y2 minus y1 divided by x2 minus x1. And it's also equal to the change in y over change in x. How are your y values changing reading down the table of values? They're increasing by 15. So my change in y is 15 divided by my change in x. Reading down the table of values, how are my x values changing? Well, they're increasing by 2. 15 divided by 2 is 7.5, which also happens to be Amir's pay per hour. Remember that we talked about how rate of change and slope are all the same. Here is our rate of change, or our unit rate, which also represents slope. So creating my equation, P is equal to 7.5 T. That's my equation. Now I'm going to substitute the value given to me in part C. It says, how much does he make if he works 9 hours? So I'm going to substitute T is equal to 9. And I'm going to solve for P. The question is asking, what is his pay? P is equal to 7.5 times 9. 7.5 times 9 is 67.5. Therefore, Amir earns $67.50. I'm going to add a zero after 5 in order to have 2 decimal places, because when we're dealing with money, there should always be 2 decimal places for 9 hours of work. Partial variation. A relationship between 2 variables in which the dependent variable is the sum of a constant number and a constant multiple of the independent variable. A partial variation is an equation in the form y is equal to mx plus b, where b represents the fixed or initial value of y, also known as the y-intercept, and n represents the constant of variation. So there's a few things that are similar and a few things that are different between partial and direct variation. What's similar is partial variation and direct variation both represent straight lines. Direct variation, we learned, will go through the origin. Here is an example of direct variation. My line is going through the origin. If my line is not going through the origin, it is partial variation. And this is an example here of partial variation. It could be anywhere else, this line passing through the y-axis, but not meeting at the origin. But this is just one example. The constant of variation is the same for both direct and partial. The constant of variation is your slope. What's different is the equation. If you look at the equation for partial variation, you'll notice that it starts off exactly the same as the equation for direct variation. The only difference is that there's also this plus b here. This plus b right here is your y-intercept. Where does the line intercept with the y-axis? That is your b value. If the line was passing through the origin, your b value right here would be equal to 0. So that's why the equations are different for direct and partial variation. Direct variation, the equation is just y is equal to mx because your b value is 0. And when writing an equation and it's just plus 0, we wouldn't include it. We would just omit it. It would just be y is equal to mx, because there's no point in saying y is equal to mx plus 0 when you can simplify it to y is equal to mx. So it's important to note that b is the variable for your y-intercept. So what can change is y and x can change for any other variables, but what has to stay as the variables assigned is m and b. M stands for slope, b stands for y-intercept, but y and x can be replaced with any other variable. The graph below illustrates the total cost, C, in dollars of an Uber fare for a distance, D, in kilometers. The graph tells me that our distance is our independent variable. And our cost is our dependent variable. Another thing that I know by looking at this graph is that this is an example of partial variation. And I know this because the line is not passing through the origin. This means that b has a value that's not 0. Remember, when b is equal to 0, that would be right here. That means that the line is passing through the origin. If b doesn't equal to 0, it means that this is partial variation. And in this example, b is equal to 2. The fixed cost of $2 represents the initial Uber fare. The distance traveled by the Uber determines how much more you have to pay. The further the destination, the more the Uber will cost. In this case, Uber charges 50 cents per kilometer. The equation can be written as C is equal to 0.5D plus 2. So 0.5 is your slope. Another word for slope is variable. Another word for our y-intercept or b value is fixed or initial. So in a word problem, when you see the word variable, that is describing the slope. If you see the word fixed or initial, that's describing the y-intercept or your b value. Example 1, identify the following equations as direct or partial and explain why. Equation A is y is equal to 4x. There is no b value. This is in the form y is equal to mx, which represents direct variation. Let's look at the next one. Y is equal to 3x subtract 1. There is a b value in this equation, therefore this is partial. And the next equation is rewritten in the way that we're not used to seeing. Instead of y is equal to mx plus b, it's written in the form y is equal to b plus mx. And of course, it's not using y and x, it's using b and d. But y is equal to mx plus b is the same as saying y is equal to b plus mx. It's just rearranged. So this is partial. Complete the table of values given that y varies partially with x. So it tells us in the question that this is partial variation. Y varies partially with x. So that means that the origin, it cannot be a point in the table of values, which it's not. If you look over here, when x is equal to 0, y does not equal to 0. Now we must complete the table of values. Let's try to find the relationship between x and y in order to help us fill in the missing values. As x increases by 1, y increases by 3. As x increases by 1, y increases by 3. As x increases by 1, y increases by 3, which means that this is 15. Moving on, as x increases by 1, y increases by 3. 15 plus 3 is 18. Let's look at the last one. To go from 18 to 27, this is not increasing by 3. This is more than 3. It's actually increasing by 9, which means that there's a few rows of this table of values missing. And they did that on purpose. They want you to think about this. So we need to find what slope is. Using slope is equal to change in y over change in x, I'm going to find what slope is. So my change in y, my y is changing by 3 as x is changing by 1. 3 divided by 1 is 3. So my slope is 3. Using the same slope formula, I know that slope is equal to 3, and my change in y for the last row is 9. So my y is changing by 9. So now I'm trying to find my change in x. How is x changing when y is changing by 9? I'm going to rearrange this formula. I'm going to bring my change in x to the other side so it becomes multiplication. So that will be change in x times 3 is equal to 9. And then I'll bring my multiply by 3 to the other side so that my change in x is isolated. 9 divided by 3 is 3. So that means as y is changing by 9, my x is changing by 3. So my x value here is 7. Identify the initial value of y and the constant of variation from the completed table of values. Then, write an equation relating y and x in the form y is equal to mx plus b. And it's asking us for the initial value of y. Now remember, initial means b. And constant of variation means slope. Going back to part A, it's asking us for the initial value of y, which means it's asking for our b value. Your b value is when x is equal to 0, what does y equal to? So in the table of values, when x is equal to 0, y is equal to 6. Therefore, b is equal to 6. And we already determined that our slope was 3. B is equal to 6, and m is equal to 3. And now it's asking us to write an equation in the form y is equal to mx plus b. Now remember, you're going to keep y and x as is and only insert values for m and b. So y will stay as y. We just found that slope is 3. X will stay as x. And we found that 6 is equal to b. And finally, it's asking us to graph the relation. Starting with my x and y axes. And numbering my axes. Now I'm going to plot the points that were given to me in the table of values in part A here. 0, 6, 1, 9, 2, 12, 3, 15, 4, 18, and then 727. And then I'll connect my points with the ruler and draw an arrow. And now that I have an equation for this line, I'm also going to include it by labeling my line with my equation. I complete the graph. Example 3. Your school is planning an awards banquet. The cost of renting the banquet facility and hiring serving staff is $675. That is not going to change. No matter how many people come to your banquet, it's going to be $675 to have staff working. So that's a fixed cost. It does not change. There is an additional cost of $12 per person for the meal. How much you're going to spend on meals is going to vary according to how many people come. So this $12 per person is your variable cost. It will vary according to how many guests you have. Identify the fixed and variable cost of this partial variation, which we just did. Now remember, your fixed cost is your B value, and your variable cost is your slope. Write an equation to represent this relationship. So because we have a B value, this is going to be partial variation. So the equation is going to be in the form y is equal to mx plus b. Y and x will stay as variables, and our slope we found is 12, and our b we found is 675. Use your equation to determine the total cost if 500 people attend the banquet. So y is equal to 12x plus 675. Reading this, our total cost is our y. To run the event and to pay for the entire banquet, how much is it going to cost? That's why y is isolated on the left. Everything else, what it's going to cost you to run the event, is on the right. Your x is how many people are coming to your banquet. We are multiplying the number of guests by the cost per guest, 12 times x. $12 per person times how many people. And the question is telling me 500 people are coming. So I'm going to sub 500 for x. And I'm going to determine the total cost. Determine the total cost. Find y. Y is equal to 12 times 500 plus our fixed cost. 12 times 500 is 6,000 plus 675. That's 6,675. Therefore, it will cost $6,675 if 500 people attend. Last example. A gym offers 2 plans for monthly memberships. Membership A offers $3 a visit. So every time you go to the gym, you pay $3. Membership B has a sign-up fee of $8. So no matter how many times you go to the gym, 0 times or 100 times, you're going to pay $8 to sign up. So that's fixed. It's not going to change. This is your fixed cost. And then on top of that, it's $2 a visit. So $2 per visit, that is your variable cost. Membership A also has a variable cost. It just doesn't have a fixed cost. Already, just by reading the membership details, I know that membership A is a direct variation, and I know that membership B is a partial variation because it has a fixed cost. Graph both relations for 0 to 10 visits in 1 month. When creating a table of values, I need an independent and dependent variable. So we're comparing the relationship between number of visits and how much it's going to cost. So, of course, the more that you go to the gym, the more it's going to cost you. So, your number of visits per month is your independent variable, and the total cost for the month is your dependent variable. When creating a table of values, I'm always going to begin with x equal to 0. And then I'm going to increase by 1 because it's asking me to increase by 1 all the way to 10. Now we need to fill in our y values. I'm going to begin with membership A. Now it tells me it's $3 a visit. So if I don't go to the gym, I don't have to pay. So when x is equal to 0, y is equal to 0. And if I go one time, I'm paying $3. So every time I go, I'm paying $3. So that means that my change in y will be 3 as my change in x is 1. So x is increasing by 1, y is increasing by 3. So my slope here is 3. I know this because slope is equal to change in y over change in x. My y is changing by 3 while my x is changing by 1. With 3 over 1 is 3. Converting my slope into a rate of change, membership A is $3 per visit. Let's complete the table of values for membership B. Now it tells me that even if I go 0 times, I still have to pay that fixed fee of $8. And then it's $2 every time I go. So as x increases by 1, my y will increase by 2. $2 every visit. X increases by 1, y increases by 2. Finding the slope for membership B, change in y over change in x, which is equal to 2 over 1, which is equal to 2. And as a rate of change, my slope is $2 per visit. Now that we have two table values, we can graph them on this grid over here. My independent variable is number of visits. And my dependent variable is cost. Now I'm ready to plot my points. Membership A, I will plot in pink. I'm going to label this with membership A. Membership B will be in purple. From looking at my graph, I know that membership A is direct variation because it passes through the origin, and membership B is partial because it doesn't pass through the origin. Looking at my table of values, I know that membership A is direct because it contains the coordinates 0, 0. And I know that membership B is partial because when x is equal to 0, y is not equal to 0. Classify each relation as direct or partial variation. Now it's asking us to write an equation for both. So knowing that membership A is direct variation, it's going to be in the form as y is equal to mx. Whereas membership B is partial, so the equation will be y is equal to mx plus b. I'm going to substitute my slope values that I found. And to substitute my b value, when x is equal to 0, what does y equal to? And that will be my b value. Last question. How would you advise someone who is looking into purchasing a gym membership? Let's first look at the graph. Membership A and membership B. Membership A starts off cheaper than membership B. I know that because membership A's line is underneath membership B's line up until 8 visits. At 8 visits, they intersect. They both share the point 824. At 8 visits, both linear relations intersect, which means that they both share that point. At 8 visits, they cost exactly the same amount, $24. After 8 visits, membership B is actually cheaper than membership A. I know this because membership B's line is underneath membership A's. How would I advise someone? I would tell them that if they're planning on going to the gym less than 8 times a month, membership A would be cheaper. If they're planning on attending the gym more than 8 times a month, membership B would be cheaper. If they're planning on going to the gym exactly 8 times a month, then it actually doesn't matter which gym they choose because they cost the exact same amount. So this point of intersection tells us that both gym memberships cost the same amount at 8 visits. They both cost $24. There are some homework questions for you here to consolidate your understanding of partial variation. Great job today.